Chapter 2. Chapter 2 is all about solving equations that have one variable in them. So at the beginning, let's talk about some basic terminology here. The first one, multiplicative inverse. So it's a big, ugly word, basically for a reciprocal. Reciprocal. So if you know what a reciprocal is, which is just a flipped fraction, kind of like 3/4 and 4/3, those are reciprocals. So you are going to use a multiplicative inverse to solve some equations today. So let's move on down here. And let me change that. There we go. So let's move on down here and actually get to some solving of equations. So it talks about the inverse property of multiplication. So just like a multiplicative inverse is the opposite, basically what the inverse property says is that if you take a number such as 7/8 and times it by 8/7, it's 1, which is the inverse of everything. So the product is always 1. So reciprocal of 7/8, 8/7, if you multiply, you'll get 56 over 56, which is 1. Also applies to negatives. If the original number is a negative, the reciprocal, or multiplicative inverse, which is the same thing, that is also negative, because a negative times a negative will have to equal a positive 1. All right. So the numerical factor of a term that contains a variable is called the coefficient. So we've talked about this, and I know I've talked to you in explanations of things. If you have something 3x, the 3 is called the coefficient. The x is a variable. So that's something that you need to keep straight. So if I say, what's the coefficient of this term? It just means, what's the number in the front? All right? So if I give you something like 3/4 c equals 18, which is the first example here. Solve 3/4 c equals 18. Check your solution. Now we'll talk more about checking in just a minute, but first let's just get it solved. The idea for solving any equation is to get the letter by itself. And in algebra, you know that if there is no number in front of the letter, it is a 1, right? So you basically want the number in front of the c to be a 1. So when you have a fractional coefficient, such as this, you actually have two choices. Same procedure, really. So we want it to be a 1. We just learned about multiplicative inverse, and we said that any number times its reciprocal, or multiplicative inverse, is 1. So if I have 3/4 c equals 18, I can get this right here. I can get this number, 3/4, to be a 1 if I multiply it by its reciprocal. Now, the cardinal law of equations say that whatever you do to one side, you have to do to the other. Well, I can't multiply that side because that's a whole number and that's a fraction. Well, then make it a fraction. All right? This side, those will cancel, right? Because it'll be 12 over 12, which is just 1. So you do not have to put the 1 in front of the c, but you can. This one, when you multiply fractions, just a refresher, it's top times top, bottom times bottom, but sometimes those can be rather large, so you can cancel diagonally. 3 goes in there once, 3 goes in here 6 times. There's nothing else you can cancel diagonally, so that leaves my answer to be 24. So C is, in fact, 24. Now, I said that there was more than one way to do this. So here's my other way. If I have my same example, the other way to do it is if I have a number, if I divide, if you remember, if you divide something by itself, doesn't that equal 1? Right? So that cancels each other out. So whatever I do to this side, I have to do to this side. Now, if you remember anything about dividing fractions, you have the top one. The divide sign changes to multiply. Let me just write this out here for you. This is basically what we have written right here. 18 divided by 3/4. So you basically have the first one, divide sign changes to multiply, and you have to flip the second fraction. Now, doesn't this right here look very similar to this right here. It should. So basically they are the same thing. It just depends on however you want to think about it. If you would rather think about it as dividing fractions, then do that, which means you have to flip and multiply. Or you're flipping and multiplying right here. So you're doing the same process, just depends on how you want to think about it. So either way, the answer is 24. All right, let's look. They talk about checking. Basically, on an equation, there's no excuse for ever getting one wrong, because you should be able to take our answer of 24 and put it back in. If C equals 24, put it back in right there for C, which is what they're doing. So I would say 3/4 C, so 3/4 times the value I found for C, should equal 18. If it does, my answer is right. If it doesn't, then I know I need to go back and fix something. All right, I am not going to require that you check it, but often if you say, why did I miss this one, or is this one right? If you bring me your paper and say, is this one right? I'm going to say, I don't know. Did you check it? So you might want to get into the habit of doing that. All right, I want you to go ahead and pause it and try these 4 examples here at the bottom, A, B, C, and D. All right, so your answers for A is 60, B, -18, C, 9, and D, 28. So the process that went with them, I would multiply both sides by 5/1. Multiply both sides by -9/2. Multiply both sides. Doesn't matter that this one's on the other side. You can still do it. Multiply both sides by -7/6. Multiply both sides by 3/5. Multiply both sides by the reciprocal. And it's not the reciprocal of the one on the left. Sometimes it is, but it's always the reciprocal of the one attached to the letter. So you always have to look at the one attached to the letter. That's the one because you want to get the letter by itself. All right, moving on. Sometimes they're going to be mixed numbers. It has no other difference except for that you can't multiply and divide mixed numbers, and don't even try it. You have to change them to improper fractions. So I would change 1/2, 2 times 1, bottom times the whole number, and add the top. So that's 3/2s equals, and I would go ahead and change that one too. Bottom times the whole number, which is 32, plus 1 is 33. So that's what I got. And just like the other example, come on, pen. Yeah, that circle's taking forever. There we go. Just like the other example, the one attached to the letter, multiply by its reciprocal. And then cancel where you can. My answer is 11. So I want you to go ahead and try D, E, and F, which means you're going to try to take these mixed numbers and make them into improper fractions and then multiply by the reciprocal. So pause it and try those, please. Okay, so for D, you should have got an answer of 1 1/4. For E, you should have got a -11 and 17/77. And E, 2 2/5. So again, we are changing all of these to improper fractions. Even this one, if it's a whole number, it's just 108/1. So change all of these to improper fractions by taking the bottom times the whole number and add the top. All right? So if you try any of these, just like on any example, you try any of these and you're watching it and you're like, oh, I don't understand how she got that. Make sure you put a big star by it, question mark by it, something, and ask me tomorrow. Okay? All right. Moving on. Same thing, only now we have decimals. So we're not talking about reciprocals or multiplicative inverses with decimals. We're just talking about multiplying and dividing. So in an equation such as this, 3.15 equals 0.45n. So again, your mind should always be going, where is the letter? That's what I have to take care of. So when a number and a letter are right next to each other, that means multiply. So how would I undo that? Well, you have to divide something by itself to get there, to get to a 1. So I would have to divide this side by 0.45. I would have to divide this side by 0.45. So because I divided something by itself, that one went to a 1, which is what we want to happen anyway. We want everything in front of the n to be a 1. So if I take 3.15 divided by 0.45, this is what you get. And again, check it. You should be able to say 3.15 equals 0.45 times n. So if I say n is 7, I put in a 7 right there. And on my calculator, I could even check it and say 0.45 times 7. It should be 3.15. If it is correct. All right, I want you to pause it and try G, H, and I. G, H, and I. All right, before I give you the answers, I want you just to look at these real quick. What would I divide both sides by? Again, my I should go right toward the letter. So I should divide both sides by 0.7. That cancels out in front of the letter. My answer to G is 7. Next one. My I goes right to the letter. I have to divide by the same thing in order to get it to disappear. So I divide this side. Make sure you're including your decimal. You get negative 1.5. Last one. My I goes right to where the letter is. Divide it by the same thing. We want it to be a 1. So I have to divide this by a negative to get the same thing. That answer, 2.3. Okay. Let's try some guided practice quickly before you are set free, my little birds. On guided practice, I want you to try these. I'll come back. We will talk about the answers. All right. So I will multiply. Again, my mind goes right towards the variable. So I would multiply both sides. 4 over 3. 4 over 3. Because that's a whole number, I need to make it a fraction. That answer is 80. This one, multiply by its reciprocal. If it's negative, it's still going to be negative. Negative 25 over 27. Negative 25 over 27. Those cross out. Those are reciprocals. They are a 1. X is equal to 5 over 3, which you can leave it as an improper fraction if you wish, or you can change it to 1 into thirds. Oftentimes in algebra, you will see that. You will see the improper fraction. And last one, decimal. My mind goes to the letter. I divide by whatever is here. I have to divide this side by the same thing. Those cross out because I've got a number divided by itself. So my answer is actually an even negative 300. I don't have to see the letter equals. That is proper algebraic protocol, but you don't have to. All right, so good luck with those. Hopefully you tried those. If you didn't pause them and try them, you're cheating yourself out of it. So good luck to you.